Hello, everyone, and welcome to The Current. This is the North Central Region Water Network's speed networking website. I am Rebecca Power, joining from the University of Wisconsin, and I will be your moderator. For those of you that don't know the North Central Region Water Network, we are an extension-led collaboration among land-grant universities and our partners in 12 upper Midwestern U.S. states. Today, we will be exploring the benefits of green infrastructure for stormwater and for other ecosystem benefits as well. Thanks to those of you that were on the line while you were listening to the sausage get made as we were trying to work out some of our sound issues. Before we introduce our speakers, we just have a few instructions or guidance about the way the session works. So we will have all three of our speakers do their presentations first, and while they're presenting, you put your questions in the chat box. The chat box is, you can get to the chat box through a little purple tab at the lower right-hand corner of your screen. So you can click on that, and there's a little balloon that comes up. That's where the chat box is. And we will monitor those questions and have a dedicated Q&A session after our last presenter is complete. If you're having audio issues, there is a phone-in option that you can access by opening up the session menu, which is in the upper left area of the webinar screen, and you can select use your phone for audio there. There's also in the upper left-hand portion of your screen, there's a little icon with a magnifying glass that says Show View Controls, and there you can also make the view of the slides larger on your screen, though it may, just to magnify a portion of the slide, it may cut off part of the slide when you do that, but if you want to see a figure or words a little bit larger, you can go ahead and adjust there. Okay, so on to our presenters today. First, we'll hear from John McMain, who is an assistant professor and extension water management engineer with South Dakota State University. Next, we will hear from Kelsey McDonough, who is at the University of Beirut in Germany. And finally, Lisa Merrifield, a community and economic development specialist at the University of Illinois Extension. We are live tweeting this session, so you can go there and make comments if you want, or follow us there as well. Okay, so on to our first speaker. Again, John McMain is an assistant professor in Ag and Biosystems Engineering and Water Management Engineers, state specialist with South Dakota State University Extension. I'm not going to read all the introductions. I'll just let you look at those. One of the things that we do here is introduce you to experts doing great work across the region. So it's not only the materials that they're presenting, but who they are and what you can contact them for in the future if you're interested in learning more about their work. So with that, go ahead, John.
All right, well, thanks so much, and thanks everyone for tuning in today. I am John McMain, and I've been at SDSU coming up on about 2 years, and have worked with green infrastructure since about the late 20-aughts, so 2010, 2011, 2009, somewhere in there. And so I'm going to start out with a little bit of a 30,000-foot view, and then Lisa and Kelsey will kind of dive into some more details about some of the different aspects of green infrastructure. But just to start, in case anyone doesn't have a background or not a lot of exposure to urbanization and the impacts on stormwater, you increase impervious area, and that really changes the hydrology of things. And the key things that it changes is your relationship between infiltration and runoff. So kind of natural conditions, you get about 50% infiltration and only about 10% runoff. If you go over to a highly urbanized area, your runoff increases by about 5.5 times. So you're at 55% runoff and only 15% infiltration. Since South Dakota and really a lot of Midwestern states have maybe limited urban areas, there's a lot of rural areas. And so whenever I speak with stakeholders, I like to point out that any increase in impervious area is going to change that hydrology, specifically change that runoff. And so even at a 10 to 20% impervious cover, we're still doubling the runoff from natural conditions, and 35 to 50% we're tripling the runoff. So any increase in impervious cover is going to change that hydrology. And it's not just peak flows and flow rates, but that one kind of key difference is how it impacts the stream hydrology. And so typically base flow is driven by connectivity to groundwater. So infiltration connected to, so surface infiltration connected to shallow groundwater flow creates base flow. But if you lose that connectivity between the surface water or infiltration and groundwater, then there is no base flow, or there's little base flow. And so you have a lot, your events become a lot flashier. So, and so to combat that, we have green infrastructure. And so initial focus was on water quantity and water quality. So as a stormwater management technology, about early 1990s is kind of when that came about from Maryland. The Prince George's County stormwater manual, and then rain gardens kind of came out of that. And it's essentially trying to imitate that pre-development hydrology, so getting that runoff back to closer to 10% and increasing the infiltration, increasing evapotranspiration. But as we'll learn, there are many other benefits as well. And so I just want to kind of outline a few questions that remain for kind of the middle of the country. And this isn't exclusive to the middle of the country, but these questions certainly pop up. And so one is climate and weather patterns. And, you know, I think every new grant proposal has something about testing technologies for local conditions, and really that is, you know, even though we use that as a reason, it's a very valid concern, because if you have a technology that's designed for use with maybe less intense storms, maybe more frequent, that you would see if it's buffered by some type of larger water body. So thinking more in the coastal areas. And then if you have intense storm and also periods of drought, well, that's something that you have to design for and figure out how exactly you work with it. And maybe the other kind of big question is, so like I indicated earlier, any increase in impervious surfaces, well, that's going to change hydrology. And so any urbanization, any development is going to change hydrology, but people aren't necessarily thinking about impacts of that if there are few population centers. And so people can maybe understand that in a highly urbanized city, but even then it's maybe limited in terms of awareness and perception. And so that's one of the challenges that we face in kind of the upper Midwest. And then kind of covering the other things, so understanding, validating performance across, increasing complexities and scale, right? So kind of on the mechanistic scale, the parcel scale, the lot scale versus the neighborhood versus the watershed. And then function, so designing for water quantity and water quality, or are we attempting to incorporate some of these ecosystem services into it? And then time, so initially, you know, it functions well as we want it, but do we build in maintenance and resilience into our design? And so, like I indicated before, it's not just the highly urban areas, the 75 to 100% impervious surface that can impact hydrology, but it's any development. And I think that's something that we need to look for as we continue to look for opportunities to incorporate this. So I'm going to finish with discussing a project that I have going here in South Dakota, working with homeowners. But another thing we think about is the different stakeholder groups that can maybe impact or implement green infrastructure. And what are the barriers that they have to implementing those? So homeowners, well, first, just an awareness and a perception about impervious surfaces and that impact on hydrology. So knowledge about the problem, and then knowledge about the practice. So what are potential solutions, green infrastructure? And then, but just knowing about something doesn't give them the ability to do it. And so then giving them experience with actually designing solutions. So putting some hard numbers down with their particular drainage area, and then how to size a rain garden appropriately, or a rainwater harvesting system, and then giving experience to implement the solution. So then just kind of the final, like, well, does it really work, and can it work for me? And so those were barriers that I'll talk about how we addressed in this project that we have going in South Dakota. But then, so homeowners are one stakeholder group, but then you think about developers. Well, barriers that they may run into is the code may not be written to allow for green infrastructure solutions to be used in addition to or in place of complementing the gray infrastructure. And then as a developer, like, this is what you do for a living. This is your what you're investing your capital into. And so green infrastructure has to have a return on investment, which Lisa will discuss. And then at the municipality level, so kind of the other side of the coin for development is they need assurance that this works as for flood mitigation, for stormwater management, and then they need the ability to write municipal code that ensures a solution. So to ensure that developers are able to implement it based on the code that they have written. So it's a project we did working with South Dakota homeowners. We found a site in Sioux Falls, actually at a home, at a residence. And so again, we started with what is the problem. And so this was a series of workshops that we did. In the morning session, we had kind of an overview of stormwater, impervious surfaces, and questions related to that. And then also included in that green infrastructure, rain gardens, bioretention, rainwater harvesting. But then again, we wanted them to have the ability to put this in. So I went through and detailed all aspects of design for rain gardens. And then in the afternoon, we did a design charrette setup. And so we had an actual site, we had all the design parameters, and so they broke into teams and used what they learned in the morning to develop their own designs, and then presented them to the group. And so this was both a learn in the morning and then learn by doing in the afternoon. And then all participants in the workshops, as well as other community volunteers, were invited to come assist in building the rain garden. So this kind of works opposite of Field of Dreams, right? If you build it, they will come. Well, with volunteers, if they come, then we will build it. And then we're monitoring it this year to demonstrate that success. And so where do we go from here? We need to demonstrate success at small and large scale, right? But just demonstrating success, it allows for change, but it doesn't ensure change. And so we want to shift the paradigm to focus on, in addition to water quality and water quantity, also the economic impact. And as Kelsey will demonstrate, green infrastructure adds value in other ways, but these stakeholder barriers must be considered and strategically addressed. So that's it for my presentation. I am on Twitter. I'm about 850 followers away from 1,000, so I'm right there. Follow me on Twitter, but I'll hand it off to the next speaker, or to Rebecca.
Great, thanks, John, so much. Okay, great overview. And now we will get on to some other specifics and cases. So next we will hear from Kelsey McDonough, who is now a postdoctoral research scientist at the University of Bayreuth. I might be not quite saying that right, but I'm doing my best here. In Germany. What was that?
I said close enough.
Okay, close enough. All right, thank you. And she does have a secret history, as you'll see from her bio here, in this region at K-State and also at NC State on the East Coast. So Kelsey's going to be talking to us about ecosystem services benefits of green infrastructure. Thank you so much, Kelsey.
Thank you for having me. So yeah, I am at the University of Bayreuth. That's the German pronunciation in Germany. It's located in Bavaria in southern Germany. And I just finished my PhD at Kansas State University in December in biological and agricultural engineering, where I studied water resources and ecosystem services. So, and now my current position, I'm in a very interdisciplinary research group working solely in ecosystem services research, and we try to understand ecosystem services within the context of climate change and land use change over a number of different spatial scales. So to get started, for those of you who aren't familiar with the concept of ecosystem services, I'll give you a really quick introduction. Ecosystem services as a field of research came into prominence in 2005 with the publication of the Millennium Ecosystem Assessment, which defined ecosystem services as the benefits that people obtain from ecosystems. And there's 4 groups that they categorize these services as. So we've got provisioning services, which are tangible services such as food and fresh water. We have our regulating services, such as things like water purification, flood regulation, and our cultural services, which are largely user-defined, so things like aesthetic services and recreation services. And these can vary from person to person, depending on our own personal preferences and values. And then we have our supporting services, which I like to call our behind-the-scenes services. And they support all the other 3 categories of services, but they're things like soil formation and photosynthesis. And ecosystem services are really, really important because they contribute directly to human well-being. So things like food, fresh water, we need these things to survive every single day. And without services, we would lack adequate and equitable access to clean water, clean air, amongst many other things. And we would be especially vulnerable to many risks, including disease and natural disasters. The biophysical supply of ecosystem services is provided by the natural environment across a diverse set of landscapes and ecosystems around the world. The number and types of services provided can vary by landscape or ecosystem type and can be influenced by human activities and intervention in natural environmental processes. Beneficiaries are the people who benefit from or use ecosystem services, and then those people then value these services in many different ways, which can impact the way that we manage ecosystems that then provide our services. So if we think about linking ecosystem services to green infrastructure, the types, quantity, and quality of services that are provided by green infrastructure are largely dictated by the type of green infrastructure that you're implementing, and also the spatial extent and composition of green infrastructure coverage. So I really like this figure from the European Commission. It's from their report, Building a Green Infrastructure for Europe, and it aimed to highlight a number of different green infrastructure elements in a landscape that can interact to provide ecosystem services. So for example, if you look over here, we've got this green wall on the left-hand side of the screen, and this provides climate regulation services by offsetting the thermal heat island effect in an urban area. Depending on whether or not you like green walls, this may also provide a cultural aesthetic service as well. If we think about this hedgerow alongside this field where we see some cows here, we've got ecosystem services such as habitat, erosion regulation, or pollination. Our forest over here in the right-hand corner provides things like water purification services, erosion regulation services, carbon storage and sequestration. And this list is not comprehensive. So there's a number of different ecosystem services here that are being provided by all of these different green infrastructure elements. And you can design a landscape in order to provide the ecosystem services that you wish to optimize or increase. And so what I'm going to do is talk really quickly here about a few projects that I've been working on throughout my academic career, from my master's all the way up to my postdoc now, that have aimed to link ecosystem services and quantify ecosystem services that are being provided by different green infrastructure elements throughout the landscape across a number of different scales. So the first project here was part of my master's research a little while ago. It was in Wichita, Kansas, where the city of Wichita was having issues with water quality impairments due to excess bacteria, nutrients, and sediment. And so we wanted to investigate different scenarios of land use, land cover, where we would implement bioretention cells, green roofs, and rain barrels, and see what ecosystem services we would get out of varying compositions and percentages of these green infrastructure elements in a targeted area of the watershed. And so we did this using a hydrologic model where we created artificial scenarios and implemented them in this little targeted area you can see zoomed in here. And then we quantified freshwater provision ecosystem services, which is a component of both water quality and quantity, erosion regulation, which is a function of sediment, and then flood regulation ecosystem services throughout the watershed. And when we looked at the results from the model, we found some really interesting results in that bioretention cells that captured anywhere from 10 to 100% of impervious runoff provided excellent erosion regulation and freshwater provisioning services just downstream of where we implemented the bioretention cells, so at node N190 here in this figure. And then when we looked farther downstream at the outfall node, we found that the bioretention cells increased both of these services, although not enough to reach the desired level. So we saw a significant improvement, but it wasn't quite enough. Unfortunately, we didn't find any linkages between bioretention cells at this scale of implementation and flood regulation services. And we saw no impact between green roofs and rain barrels in any of the three ecosystem services we analyzed. That doesn't mean those green roofs and rain barrels don't provide a number of ecosystem services. They just didn't provide the three that we were interested in quantifying for this study. So they require further investigation to understand the types of services they provide. Part of my PhD work looked at linking spatial patterns of land covers to flood mitigation ecosystem services in the urban landscape. And this study was in the south side of Kansas City, in both Kansas and Missouri, in the Blue River watershed, where they've been having some flooding issues due to increases in population and urbanization in this watershed. And so we worked with some city planners who wanted to understand, is there a way we can optimize urban development by creating specific patterns of wetlands or forested area in order to help mitigate some of the flooding issues that we're having and provide flood regulation ecosystem services. And so we did a fairly comprehensive study between different patterns of land use, land cover, and flooding. And what we found was that if you are able to increase the percentage, density, and connectivity of your wetlands and natural non-forested land cover patches, so those are things like grasslands, for example, and you decrease the fragmentation of your wetlands and natural non-forested land cover, we can see a significant increase in the flood regulation ecosystem services that are being provided. And then when we look at what is the spatial scale of this ecosystem service being provided, we found that those areas with a blue star are where the service needed to be provided in a biophysical manner. So we needed to optimize our land use, land cover in these areas. And people could benefit from this service in the areas that are highlighted by red and yellow. And so we see a greater spatial extent of service provision from the natural non-forested land cover, but we also see a large spatial scale of provision from the wetlands as well. And so you can really begin to help mitigate some flooding events by optimizing your land cover in this way. So now I'll talk a little bit really quickly about some of my ongoing research. I just started here in Bayreuth, and so I don't have any exciting results to share with you yet, but I'm working on some really neat projects that are funded by the Bavarian government here, called Aquacliff and Landcliff, which are part of a much bigger project called Bycliff, where the objective is to develop and strengthen existing climate change research in Germany. So for those of you who aren't as familiar with your geography here, this is a map of Germany in German, unfortunately, but Bayern here is Bavaria. This is where I'm located. We're in the southern part of Germany, right next to the Czech Republic and Austria. And so we're working in the Aquacliff project to investigate the relationship between agricultural best management practices and climate change on ecosystem services in Bavaria in order to understand how we can improve services such as food production, freshwater provision, erosion regulation, and water purification services through the implementation of agricultural BMPs in order to combat some water quality issues that Bavaria is currently having with nitrate and phosphorus. And then we aim to provide recommendations to policymakers and decision makers on how to improve this water quality issues in the future. With Landcliff, we're also looking at understanding the effects of climate change under given land use changes on ecosystem services in Bavaria, and we're expanding that beyond just water hydrology-focused ecosystem services to everything, including pollination services, habitat quality, and so on and so forth. And so this is an idea of the type of output that we produce. We will create maps of ecosystem service provision throughout the entire state of Bavaria here, and we can begin to understand and identify areas where we can protect and preserve the natural environment in order to maintain ecosystem service provision, or areas where we need to interfere in the landscape in order to increase the service provision that we aim to provide. So with that, I'll take any questions. I'm happy to answer questions at the end of the presentations, or you can reach out to me at my email here as well. So thank you very much.
Great, thank you so much, Kelsey. And again, you can submit any questions for Kelsey or John, and very soon, Lisa, over there in the chat box on the right-hand side of your screen. Now onto our final presenter, Lisa Merrifield, who is a community and economic development specialist with the University of Illinois Extension. And again, you can skim just a little bit about Lisa there, and we will move right into her presentation. So thank you so much, Lisa.
Thank you. Can you hear me? Am I okay?
All good.
Oh, good, good, good. Thanks so much for having me. I'm going to switch gears a little bit. I'm a planner by training, so I'm coming at this from a little bit different angle. I want to look at, I want to walk us through some of the reasons why communities are doing these kind of green infrastructure projects, what the interest is all of a sudden. I want to talk a little bit about economic and societal reasons it's happening. There's some workforce development and social equity issues. And hopefully I'll have a little bit of time at the end to talk about financing, because that's always a big thing when we're talking about communities, particularly smaller communities. We got to make sure it works, and we got to make sure we can pay for it. So this is going to be a broad, shallow kind of look at the social science end of this. So here are a couple maps just to show how green infrastructure is showing up around the country. Let's see, can I pull a pointer over? This map here, the stormwater utilities map, isn't necessarily indicative of green infrastructure practices, but what it does indicate is, there we go. Stormwater utilities are a funding mechanism that communities use that often is related to green infrastructure, and you can see it's across the country. The map on the right is one that just came out of a publication in Climate that was reviewing landscape architects' views of green infrastructure projects. and looking at how much money had been spent. And you can see in much of the Midwest, we're putting a fair amount of money into green infrastructure projects. For those of you in North Dakota and South Dakota, this was a small study. It was only 102 sites, so don't think that that there's nothing going on in North Dakota and South Dakota, because there is. It just didn't show up in this particular set. So all that is to say, green infrastructure is happening around the country right now with increased popularity. I've done a little bit deeper dive in Illinois, where I looked at municipal separate storm sewer permitted communities, which is a specific kind of storm sewer permit. And what we found, and this is a little bit hard to read, but is that 67% of the communities with this particular permit are actually using green infrastructure to help their water quality. And of those, 36 communities are doing 3 or more practices, which is indicative of having kind of a mature program. So I would assume that most other places look similarly. Of course, in Illinois, you can see where Chicago's located, and there's a lot of activity, but there's also a lot going on downstate and in the smaller areas. So why are people doing this? Why all of a sudden, for years we piped water underground and got it away. So why are we transitioning, and why are we trying to do more natural solutions? So there are federal regulations that require cities to do certain things. Those haven't really changed. One of the things that has changed is these municipal separate storm sewer permits, and to some extent the combined sewer overflow permits, which are what cities have to comply with, the percentage of certain chemicals that can come out of the city and that kind of thing, the things that they have to take care of in wastewater treatment plants. And increasingly, states are suggesting, if not requiring, that communities incorporate more nature-based design, or as the rain gardens and some of the practices Kelsey showed on the map. Another thing that I think is really changing is that increasingly younger populations are more sustainability minded. There's a body of research that's kind of indicating that younger people have grown up with climate change and are more accepting and more interested in communities that are more sustainably focused. And a third thing that I think has really changed is, as our peak storms increase, and as we're looking at the Mississippi flooding, certainly green infrastructure won't solve those kinds of problems, but on a smaller scale, green infrastructure does keep water out of basements and does help communities kind of deal with increased rainflow that they might not be able to deal with by putting more pipes underneath the ground. So I think that's why we're seeing changes right now. Another big reason we're seeing an increase in green infrastructure interest is the economic benefit. And I pulled numbers from Philadelphia because that's what I had handy. There's been some research in Chicago and Milwaukee and Cleveland, Minneapolis, that show kind of similar trends, that by using green infrastructure, there's a real economic payoff, not only in decreased flooding, but in societal benefits, which we'll talk about in a minute. And then in the environmental benefits, the water quality is improved. And kind of the way they get at this economic drivers is there's some research most recently out of I believe, University of Oregon, looking at proximity to green infrastructure and what that does to housing prices, and then translate that into what that does to property tax revenue. Over on the right side, I pulled some infographics from the National Resource Defense Council, where they've done some research to indicate that people are willing to pay more, consumers are willing to pay more in malls and spaces with mature trees. And another study they did looked at rental space in offices, and in office space with nice landscaping with rain gardens and bioswales and things that keep the water away and make it more a more inviting environment, that those rents are increased. So economics is a really huge reason that this is becoming an increasing trend in cities. I also wanted to share the societal benefits, and Kelsey touched on this a little bit. This is from the Center for Neighborhood Technology, which is out of Chicago, and they do a lot on rain-ready kinds of things. So we know about the reduced stormwater runoff. We know about some of the water quality practices, but there's a real livability component. Oftentimes, green infrastructure is a park. It's a pretty place, and so that's so it has some qualities that are hard to maybe quantify, but may reach other goals that communities have. And I want to touch on equity and social justice. One thing that green infrastructure allows a community to do is maybe reach some social justice goals in different ways by encouraging communities to incorporate green spaces. This picture with the flooded street, that is actually at the University of Illinois campus. It's the main kind of retail and restaurant corridor in campus. And that picture was probably taken in the 60s or 70s. But that continued into the 90s and early 2000s. That street, with heavy rainfalls, would flood, and it was awful, and it was expensive. And so in the mid 2000s, 2005, 2006, the University of Illinois campus, coupled with Champaign and Urbana, the surrounding cities, started to do some green infrastructure practices. They started to try to put parks in areas and create a greenway along the stream that was flooding. And as you can see from that picture, it's now a beautiful area in an area that was not maybe as desirable. We had some lower income housing and some buildings that were not being used. So this park is now used as a recreational space. There's clearly a walking path there. There's some playground equipment, but it's got a ton of capacity to hold this water. And they've done that throughout the city. And it has allowed that green space to go into areas that might have been previously underserved in that way. I also want to chat about maintenance and job opportunities, because one of the concerns we hear about green infrastructure is that maintenance is hard. It's different. We don't know what to do, and I think there is something to that. When we put a pipe underneath the ground, we've got some expectation that we're not going to have to touch it for some amount of years, and nobody's going to see if it starts to crumble or fail. Whereas green infrastructure is a garden above ground. It's a park people walk through, and so the maintenance requirements are different. But arguably, if we're going towards those social justice goals, maintenance of green infrastructure employs people who potentially may be underemployed or at-risk youth or that kind of thing. And I think, as we shift the mindset in communities, I think the maintenance issue will become a positive rather than a negative. It's not that the green infrastructure has to be maintained regularly. It's that we can now employ more people in our city. We have jobs. So there's been some research done that it looks like there's about 200,000 green GSI's green stormwater infrastructure positions around the country right now, with the expectation that will increase as more communities implement programs and plans. And there is actually a movement from the Water Environment Federation, which was promoted from cities to standardize what green infrastructure looks like. So there's actually a national certification program that has started. And there are probably a couple hundred people around the country who've been certified at this point. So we're starting to get some standardization. I'm going to skip through this, but there are some. Minneapolis is a great opportunity. They are really doing a good job of combining their green infrastructure programming with some workforce development. And we are also starting a grant project funded by the North Central region that is trying to give us, to help us catalog what's going on in the region in terms of green infrastructure projects, and then looking at those coupling that with the social justice aspects. So in about a year, we'll have more information on what the region looks like and kind of some of the bright spots. Last thing on my agenda was to talk about how to pay for it. This is a huge issue. This study just came out in Climate a few weeks ago, looking at how cities are paying for green infrastructure. Public green infrastructure seems to be paid for primarily through EPA 319 grants, which deal with stormwater. So that seems to be federal funding. More interestingly, I think, is private and public-private spaces are getting funded through donations, which is an interesting thing to start looking at. And in my final slide, this is from the Conservation Finance Network. There's a nascent kind of field of work going into how we fund things now that maybe state and federal financial resources are not as prevalent as they used to be, or maybe harder to come by. So there are some interesting interesting avenues, and I will leave it there because I'm out of time. But thank you so much, and hopefully that gives you some overview and some insight.
Great, thank you so much, Lisa. And we will go back and begin with the questions in the chat box. And again, just a reminder for our participants there on the line, if you have any other questions for our presenters, go ahead and put them in the chat box. So we'll start with Leland's first question. Leland asking some excellent systems kinds of questions. But first, Leland is talking about the problem of ecosystem services and supporting ecosystem services in Iowa, probably most of our states, related to soil erosion and suburban sprawl. So, is any advice from our presenters on how we convince developers, municipalities, legislatures, and others to really support, I'll put it in the positive, support ecosystem services? So any of our presenters can go ahead and address that.
I think from the work that I am doing, I approach green infrastructure and kind of the nature-based design solutions. I talk about the money first, because it seems in small governments that as soon as we start looking at those economic numbers, then it becomes more interesting and more possible. So the more case studies we have to do those kinds of things, I think the easier it is to have those conversations. I also think, we've had a surge of early adopters. We're kind of in that phase, and we're starting to move into that part of the bell curve where those that are interested but haven't been quite convinced are coming on board. So it's an interesting time. I would guess we're going to see more and more of these kind of practices because they meet multiple goals for communities.
I would add on to that as well. One thing that we try and do when we're talking with stakeholders here in Germany is, in addition to the monetary aspect of, this is a cost avoidance strategy, this is how much it will cost you if you don't invest in green infrastructure now, we also try and share all of the other benefits that they would get by implementing this green infrastructure, all of the ecosystem services. They might be going for erosion regulation services, but you're also getting all of these pollination services and all of these other wonderful benefits that are going to reap benefits for the area that's investing in green infrastructure today.
Yeah, I'll just add a little bit. I definitely emphasizing the full portfolio, if you will, of benefits that green infrastructure can bring. The other, I guess, key point that I think about is not shying away from the complexities and potential barriers that they would have. So, for example, a lot of municipal code for compaction and for lots is based on soil structure and structural stability for buildings, and so understanding that might be a need for kind of structural stability and having some level of compaction a lot, but not using that as a excuse to not invest in infrastructure, but using that as a point to innovate from, I guess. So I guess my big takeaway is you got to know your audience, know your stakeholders, and know what their barriers are to change, and then work to overcome those barriers.
Great, thanks everybody. I'm gonna see if I can combine Leland's next couple questions, and so the first question that Leland, or comment that Leland is making, is about many detention cells, that those cells have the effect of shaving off flood peaks but not reducing lower flood flows, which are damaging to waterways. Well, and I guess I'll ask that, how do these play into both hydrology and green infrastructure? And I'll just say, it seems like, Leland, you're talking about maybe not only some potential trade-offs between large projects and small projects, or gray infrastructure and green infrastructure, but maybe how these could work together. So I guess I'll ask our presenters if they want to address any of Leland's points there specifically, and also to talk about, maybe like how green either at the household level or more broadly, like the park that Lisa, you were looking at, how that fits in with our other options for natural resource management in urban and suburban areas.
So I would say that we have gray infrastructure in place, and it was put there for a purpose at one point in time, and now we're understanding that we need more functionality, or different functionality. And so I think that's the way I would go about it is, okay, so detention basin, like you say, it works to address peak flows, but doesn't address overall flow reduction. And so that's the purpose of the detention basin. So now, and to be honest, for development, detention basins were put into code. And so that's why you see a lot of detention basins. And so I think bringing that to the municipality and working, again, kind of going back to the previous point, making sure that code allows for and emphasizes additional ecosystem services, so total volume reduction, a lot of the other things like that has to get to the point where it's understood and put into code, so then you can start building, additional functionality into that.
I think the code piece is interesting. We see this on the solar and wind power side of things too. If communities are interested in doing these kinds of practices, it really helps if they can think about it ahead of time and set up, their codes and their policies and their permit systems so that they're not trying to implement a project and figure out what kind of policies they need in place to do it at the same time. So easier said than done, but to John's point, I think having thought through it ahead of time is sure helpful.
And Lisa, did you have anything to add to Leland's specific question about how green infrastructure I guess he says allows implementation of large, or maybe integrates with large scale stream restoration work?
I think it's all connected, and I think sort of like recycling was maybe a gateway to getting people to think about larger businesses and waste streams and that kind of thing. Green infrastructure is sometimes a more local scale that, if at a local scale this is what we can do. Look at what we can do at a larger scale if we do some of this, some of the wetland redevelopment, and we really look at hydrology and we make sure that we're using land appropriately. So I think it's a rain garden is not going to solve Mississippi River flooding. However, looking at this as a practice across an entire landscape, we probably can minimize to some extent the damage that gets done and the cost for businesses and communities. So I think it's a good practice. People can see it. It's pretty, and then they can understand the broader consequences of land use decisions.
Great, thanks, Lisa. And Dave, just to check in, I went back to this. I think this is the right slide, and just let me know if you have any additional questions about this slide. And while you type, I'll go to Jessica. And Jessica's asking a question about when talking with stakeholders, do you present charts from studies or create your own graphics or bullet points based on overall economic and financial benefits, or does it depend on the audience?
For me, it depends.
I would say for me, oh, go ahead. Go ahead, Lisa.
Oh, no, go ahead.
Okay, I was going to say for me, it really depends on the audience and also the situation, the context that I'm in. So if I'm giving a presentation, I really like to utilize a lot of graphics. I'll pull graphics from other people, presentations that I've sat in on, but if I'm not giving a presentation and it's more one-on-one, we'll go do site visits and we'll show people how this is working and how it's providing these ecosystem services and improving water quality and so on and so forth. And so I would say it really depends on the audience, but also the context. And the more figures I think that you can give them and exposure to the actual green infrastructure that you're talking about. So if you can go do a site visit, I think that's always extremely valuable so they can really understand what's happening and what they're dealing with.
Great, thank you. And I'm going to move on to Pat's question now. And Pat, I had the same question when Lisa was talking, so thanks for this. I'm interested in how green infrastructure impacts housing values in low-income areas. Does making these improvements and subsequent increase in housing values drive out lower income residents? So what's this relationship between creating more livable communities and gentrification?
This is a huge balance, and thank you for letting me touch on this. Atlanta, Georgia actually had a really interesting case study. They had a community that they put a really nice green infrastructure path through, and it was a lower income community, a very diverse community, and it drove up housing prices and it drove people out. The people they were trying to help could no longer afford to live in that area. And I don't think there's a ton of work that has been done on this, but it's something I am keenly interested in. There are the last study I saw, so there's a proximity indicator. The closer you are, the higher your property value goes up. But I think we need to be careful of this, and I think we need to be really thoughtful in communities about making sure that we're not advocating for practices that in fact end up making our social justice situation worse. So yeah, but if you're interested in kind of where we've seen this in action, Atlanta is the kind of the case study du jour in that for that kind of thing.
And I would just throw in, I would say it would depend on the type or the implementation of green infrastructure. So some more visible types, for example, I think would have more of this impact. But maybe something as simple as looking at soil management, while that's going to greatly improve, have a lot of benefits for water quality, water quantity, and also provide additional ecosystem services, it may not be the one that specifically impacts property values. So I think there's ways to work within the space to address that. But yeah, that is a really good question and something that needs to be considered.
Okay, I see Chuck is typing. I'm going to ask a question going back to this mix of approaches issue. Kelsey, you pointed out where there were a couple of places that you put practices in the green infrastructure practices in a watershed, and at the outfall, it wasn't sufficient to make a difference. Are you doing any work? Are you aware of any work on, sort of a comprehensive treatment approach in watersheds and how those plans are put together? And, if so, back to this question of, very localized approaches versus larger, more larger treatment type approaches. And is there any information on that kind of mix in terms of, in this case specifically, treatment of flow and water quality impacts at an outfall?
Yeah, it's still something that I think a lot of people are trying to figure out, is how does green infrastructure interact over a larger spatial scale to provide some of these ecosystem services or water quality or whatever you're trying to do and improve in your landscape. How do they interact, and how can we utilize it over a large scale in order to achieve this? And while I will say we didn't achieve the desired level of water quality that we wanted in the watershed in Wichita, we did see improvements. And so part of our conclusions in that paper were, okay, so if we expanded the number of bioretention cells and really began to study the spatial configuration and pattern of their implementation, and we're very strategic, would we be able to achieve that desired level of water quality improvement at the outfall? And so that's still something that we're working on, and I think there's a number of other research groups that are also looking into that to try and understand how can we really optimize a system. But it's more than just ecosystem service or than just green infrastructure, looking at the land use, land cover in that area, the type of gray infrastructure that they have implemented. And so it can be pretty complex.
So stay tuned. Okay, will do.
Exactly.
All right. Well, thank you everyone for participating. We've got a couple more minutes here, so I will continue to watch as we close out here to see if anybody has any final questions. We really appreciate your participation, and thanks for interacting with us. There's a lot of expertise out there as well as with our presenters, so it's the conversation is valuable and important. You can visit our website, northcentralwater.org, to access the archive. And let's see, Chuck says, I'm moving over to Chuck's question here, or comment. Okay, so our state is, final question here, our state is working on a statewide multi-agency effort for flood mitigation. It will include hydrologic and hydraulic modeling as well as outreach. The idea is that models would be able to evaluate the impact of proposed flood mitigation projects as well as proposed developments and land use changes. Many in the public tend to focus only on dredging and clearing. And let's see, and snagging, which can have water quality and ecological impacts. How can the program be directed to include green infrastructure and other nature-based projects that result in win-win situations? Who wants to take that?
I wish there were like the one easy answer. No, go ahead, Kelsey.
I was going to say, I guess I could start with that. I mean, with modeling, that's exactly what I do every day. We do a lot of hydrologic and hydraulic modeling in our group, and it's really easy to include different scenarios that test green infrastructure and nature-based solutions in those models and see how they impact the results. And it doesn't take too much more work in order to be able to pull those into a model and see the results. So from a modeling perspective, you can easily incorporate that into there. Perhaps someone else can speak on convincing them in order to expand that focus. I'm not quite sure how, but it can easily be done in order to, from a research perspective, I guess I could say.
Well, and thank you, Kelsey. And in the interest of time, I'm going to say, Chuck, definitely contact Kelsey, and she, maybe the two of you can help each other out. And thanks for that question. Thanks, everybody, for participating. The next North Central Region Water Network webinar will be on Wednesday, June 12th. And we will focus on groundwater, TBD on speakers and more specific titles. And you can visit northcentralwater.org/thecurrent for more information. Thank you so much for joining us today, and thanks again to our presenters.